Hello students, how are you all? Welcome back to Akshar IIT Foundation classes. I am your chemistry faculty S. Mohan. Students, under IIT Foundation class 6 chemistry, we are discussing about the periodic classification of elements. Students, here you are in 6th class, so just about the classification of elements, introduction only. The small introduction part is introduced in your 6th class. Okay. So, it consists of only 2 synopses. The first one already we discussed in the previous classes, and this is the second one, periodic classification of elements, synopsis 2. So, students, synopsis 2, this is the last topic of your volume 1, right? So, students, in the previous class, what we discussed is there are total 118 elements. How many elements as on today? 118 elements. And these 118 elements have different physical and chemical properties. So, it will be difficult to any person to remember the properties of all these elements, right? So, that's what the scientists are tried to classify the elements, right? So, in that first the elements are classified into 2 types only, like metals and non-metals, and then a scientific way, in a systematic way, the first classification of elements was attempted by the Dauberinier. This already we discussed in the last class. So, Dauberinier, he classified the elements in the year 1817 and is almost 200 years back from now, right? So, at that time the number of known elements were very less. Okay, the number of elements were very less. So, he classified the elements into triads, already we discussed. Okay, so what is in the triad? So, he classified the elements into some groups. In every group, he arranged three elements having similar properties, right? So, these are called the triads. And one more important point also, he said that when these elements in the triads, when we arrange in the increasing order of their atomic masses, then the atomic mass of the middle element is arithmetic mean, means average or approximately average to the first and third elements, right? So, this is the Dauberinier classification, but here defects are there. So, the main important defect is that he classified the elements into only few triads and other elements he didn't classify. Okay, and second one is that when the new elements were discovered later, there was no place for the new elements in those triads. Triad means what? 3. Already 3 were there. Now, if one more element is discovered, there is no place for other new elements for these triads, right? So, that's what this classification was failed. So, till here we discussed in the previous class, right? So, today we are going to discuss about the Newland's concept of octaves or Newland's law of octaves. Okay, so today's our topic is Newland's law of octaves. Okay, so this is the today's topic, right? Newland's law of octaves. So, Newland's law means it was proposed by the John A.R. Newland, his full name, and he proposed the law, and this is called law of octaves. Why? Because he said that if the elements are arranged in the increasing order of their atomic masses, then every eighth element possesses the similar properties that of the first element. Okay, so that's what it is called as the octaves. Oct, students, here oct means 8. Oct means what? 8. Okay, so every eighth element has the similar properties that of the first element, right? So, Newland classified the elements in the year 1853, okay, near to that 1853. At that time the number of 1863, at that time the number of known elements are very less, okay, very few elements, means only 57 elements might be there, and whatever the elements were there at the time, arranged all the elements in the increasing order of their atomic masses. Atomic masses. Like for example, if you see students here, like lithium, okay, beryllium, boron, carbon, nitrogen, oxygen, fluorine. After fluorine, which element comes? Neon. Neon is what? Inert gas or noble gas, which were not discovered, when this classification was attempted, right? So, no neon. After neon, what it comes now? Sodium, right? Sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, right? After chlorine, what it comes? Again, argon. Again, argon is what? Inert gas. So, inert gases were not discovered. After chlorine, next it comes what? Potassium, calcium, scandium, something like this elements. Okay. So, I arrange all these elements like this in the increasing order of their atomic masses, right? Then, what he found that the elements in these elements, if the elements are arranged in the ascending order of their increasing order, ascending order of their atomic masses, every eighth element will possess a similar property that of the first element. Okay, every eighth element possesses similar property that of the first element. Means, for example, if I take the first element as lithium, okay, so I'm rounding off here lithium. If I count from the lithium, so 1, 2, 3, 4, 5, 6, 7, 8. So, which element is the eighth element? Sodium. Okay. So, he said that whatever the properties, okay, of lithium, the same properties will be repeated in the sodium. Okay. Now, for example, we start counting from sodium. 1, 2, 3, 4, 5, 6, 7, 8. So, eighth element is what? Sodium. Whatever the properties present in the sodium, the same properties will be repeated in the potassium. Means what? All these three elements have the similar properties. Is this understood? And this already we observed that this lithium, sodium, potassium are also Dauber-Linier triads. Dauber-Linier triads. The Dauber-Linier triads we discussed on the first triad is what? Lithium, sodium, potassium only. Okay. So in the triad here is the three elements, the similar properties. So here lithium, sodium, potassium are the similar properties. Is this clear? So every eighth element has the similar properties that of the first element. So every eighth element has a similar properties that of the first element. Okay. Now you see students here. Now here, how can you remember this one easily? So you know that musical octaves. In Indian music, you know, sa, re, ga, ma, pa, da, ni, sa. Okay. So sa is what? The first letter. Starting with what? Sa. Sa, re, ga, ma, pa, da, ni, sa. Okay. So eighth element again sa. First is sa. Eighth element is sa. Okay. So like this you can remember that first and eighth are sa. Sa is repeating. Okay. So you can say, for example, if you are starting from here, you think. Okay. So from here if you are starting. Okay. So then it becomes sa, re, ga, ma, pa, da, ni, sa. So see here again sa has come to magnesium. So same. Clear? Now similarly again sa, re, ga, ma, pa, da. Sa, re, ga, ma, pa, da, ni, sa. Right, sa. Okay. Again it is coming sa. So beryllium, magnesium and calcium. Okay. They possess the similar properties. Is this clear to you? So like this Newland proposes law of octaves. Very simple. No? If the elements are arranged in the ascending order of their atomic masses, every eighth element possesses the similar properties that of the first element. Okay. So this is known as Newland's law of octaves. Understood, students? So this is about the Newland law of octaves. Now the question is that, okay sir, this is fine. Now are we following the same, this Newland's concept of octaves means? No. Why? Because this is also not valid, okay, after a few days. Okay. So here also it was not sufficient, okay, not what do you say, proper, okay, to this one. So here why? Because here there are some drawbacks over there. what are the drawbacks? So drawbacks is that here is said that every eighth element has a similar property that of the first element, right? So this is applicable only up to atomic number 20 element, means what? Calcium. Okay, it is applicable up to calcium. Here it is still here applicable. Okay, but boron, aluminium, scandium, okay, will not have the similar properties. Okay, aluminum and scandium do not have the similar properties, means what? It is not following. Okay, it's not following for all the elements, it's following only up to the element calcium. Okay, so that is one of the drawbacks. Understood? No? So drawbacks. Drawbacks means what? Failures. You can say that drawbacks means what? Failures. So in the failures, what we can say that here the first drawback is that it is only valid. Okay, this is valid up to, means octet is following this rule up to only calcium. Okay, it's valid up to only calcium. This octet rule is following up to calcium only. It's not following for the higher elements. Is this clear to you? Any doubt? Next, he said that okay, in his classification, he arranged three elements like cobalt, nickel. He arranged in the same position. Okay, which is in the form of I am not drawing here. If you can see in your material page number 176, he arranged two elements in the same column like cobalt and nickel. You can see it is arranged with fluorine, chlorine, cobalt, okay, and nickel. Okay, so here different means they arranged some element, means here the vertical column, so these which are coming in the same vertical column should have the similar properties. So different properties elements also are coming into the same column, so it is not following this one. Okay, and no place for left for known elements, so many elements are occupied wrong position. So here is what at that time he classified only some 57 elements or something. At that time only those elements were there, and he said that this much only the elements will be there and no more elements will be discovered in the future. So, but later so many new elements were discovered. For that element there was no place in his classification of elements. Clear to you? So, due to this students here Newland's law of concept was failed. So, after that after the classification of Newland's concept, the Mendeleev was another person who tried to classify the elements, and he made a lot of contribution. So, means he was the like father of periodic table. So, he constructed one periodic table, but of course later it was proved as wrong. Then one more new periodic table was constructed based on the Moseley's law. Now we are following that is called long form of periodic table. So this is all you learn in the next higher classes. So just it is an introduction, okay, till here only. So with this this periodic classification synopsis 2 is done. So with this the volume 1 of the chemistry is done. So students, the next we are going to start the volume 2. That volume 2. So with this volume 1 is completed, and we give an examination date also for this volume 1. So we conduct one exam. Okay, to you for this you have to prepare for that. Okay, and then now let's come to the few questions, means exercise you need to form. Okay, complete. Okay. Now, so questions you see in the page number 177. The law of octaves was given by. Here only it's a law of octaves is given by Newland. So option is 1. Okay. Name the scientist who noticed that 8th element was a similar property of the first element. 8th element, see 1, 2, 3, 4, 5, 6, 7, 8. Who noticed that? Again Newland. So the answer is Newland. Newland arranged the elements in. How he arranged? In the increasing order of their atomic number? No. Decreasing order of atomic number? No. Increasing order of their atomic masses? Yes. So he arranged the elements in the increasing order of their atomic masses. Okay. Now, the systematic relationship between the order of atomic mass and the repetition of properties of the elements is called periodicity. Periodic means what? A repetition of the same properties after regular interval, means after particular gap. So that is called a periodic. So the answer is a periodic. Next, in the Newland's concept of octaves, eighth element after beryllium. Element after beryllium. B is for beryllium. Eighth element is what? 1, 1, 2, 3, 4, 5, 6, 7, 8. That is magnesium. So your answer is magnesium is the right answer. Okay. In Newland's concept of octaves, eighth element of the carbon is So this carbon. So from here you can start like this: sa, re, ga, ma, pa, da, ni, sa. So eighth element after the carbon is silicon. So your answer is silicon. Next, in Newland's table, the first element which shows the similar properties with 8 element is carbon, aluminium, no, lithium, sodium, yes, lithium, sodium. Lithium, sodium is the 8th element, right? So the answer is okay, option 2, right? Now let us see the next one also. JEE Main level 1 question. Law of octaves proposed by John A.R. Newland. J.A.R. Newland is, so that is option 4. In Newland's law of octaves, the 8th element after lithium, is sodium. So answer is 1. In Newland's concept of octaves, 8th element of flow after fluorine, chlorine. Chlorine is the right answer. Which of the following pair has both members from the same period of the periodic table? Which of the following pair has both members from the same period of the periodic table? Sodium and calcium? No. Sodium and chlorine? Yes, sodium and chlorine. So see, sodium and chlorine both are in the same line. Okay, this is called period. So the answer is sodium and chlorine. So option is 2. The electronic configuration of the element is 1s2, 2s2, 2p6, 3s2, 3p3. The atomic number of the element which is just below the element of the periodic table. Say students, 1s2, 2s2, 2p6, 3s2, 3p3. First you count all the numbers at the top. Okay. So 1s2 means 2 electrons, 2s2 2 electrons, 2p6 6 electrons, 10 over plus 2 plus 3 15. So total 15. 15 atomic number is what? Phosphorus. Okay. The 15th element is what? Phosphorus. Where is the phosphorus? Phosphorus. After phosphorus, actually which element will come? Okay. So according to Newland's, that should be 15 plus 8 23. But actually in the periodic table it will not come. So below the periodic table you will get 15 plus 18. Okay. That is 33. So element is 33. So option is 4. Newland arranged the elements in the increasing order of their atomic masses. So the answer is second option.